Good morning, students. In last class, we discussed about fourth normal form, and in this session, we will discuss what are various properties of decomposition. Okay, so this is the last topic in your fourth unit. We hope we will discuss two or more additional topics to cover the entire fourth unit. Okay, right? What is a decomposition? Right? Already you know that a decomposition is a process of breaking down into large part of data into small parts so that it replaces a relation with a collection of similar or smaller relations. That is, if you are dividing a large relation called as 10 attributes based upon your properties called the first normal form, a second normal form, or third normal form, or BCNF, or fourth normal form, you are dividing that large 10 attributes into subpart of relation called the two attributes of relation or three attributes of a relation. Okay, so that it breaks the table into multiple tables in a database. So it should always be lossless because it confirms that a information in the original relation can be accurately reconstructed based on the decomposed relation. So if you are dividing a large relation into sub relations, so if you want to combine the if you want get back the original relation, so that the original relation can be get by means of some parameters called as properties. Okay, so based upon these properties, you will get the original relation when you combine the large small relations into one. Okay, if there is no proper decomposition of the relation, then it may lead to problems like loss of information. So if you are combining that large relation sub small relations into large relation, if any losses happen, then you should not do you didn't do any proper order to get the original relation. Okay, so that getting the proper order from the smaller relation into large relation or original relation, you use these two properties called properties of the decomposition. We have two properties of the relation already in the first session of this unit. You discussed what is what, but in this session you will get a complete knowledge about what is the properties of these decomposition. We have two properties of decomposition called lossless decompositions and dependency preservation. What do you mean by lossless decomposition? Right, decomposition must be lossless. That is, if you are dividing the original relation into small relation, when you combine these small relations and to get a original relation, there should not be any loss of the data. Okay, it means that the information should not get lost from the relation that is decomposed. Right, it gives a guarantee that the join will result in the same relation as it was decomposed. Right, if you use the operation called as joins, we have various joins called natural join, theta join, and conditional join, and left outer join, right outer join, and full outer join. So now what we call as unconditional, all these comes under the natural join. Okay, if you use any natural join, means combination of full outer joins, right? So if you use these join operations, either inner or outer, you get small relations are joined, so that the original relation will get by the user. Okay, so like if you have take an example, let's take E is the relation schema with instance a small e. It decomposed into E1, E2, E1, En. So I have a one relation called as table E. Now I am using various normal forms. You get the E1, E2, E1, En. Now I want to get the main relation called as capital E, so that with instances E1, E2, E1, En, if you're combining natural join operation from E1 to En, then I get my relation that is called as lossless join decomposition. Okay, in this example, that if natural joins of all the decomposition give the virtual relation, then it is said to be lossless join decomposition. Right, so if you decompose a relation R into R1 and R2, if when it is a lossy and when it is a lossless, now you are combining this R1 and R2, it will get a only part of data of capital R. I have 10 rows. Now you are combining this R1 and R2. Original relation is capital R. Now you are dividing that R into R1 and R2. Now you are combining by means of any join by R1 and R2. Now you get only some part of capital R, means there is a loss of data. If you are joining these two, you will get R data, then it is a lossless join data. So to check for lossless join decomposition using functional dependency, we have some following conditions. That is, when it is a union, you have to follow intersection, and we have to get the common attributes. Okay, when you have to following means attribute R1 and R2, you get a attribute R. The intersection of these attributes are not to must be null, should not get any particular null values. We should not get any null values, and common attributes must be a key for at least one relation. That is, our attribute R and attribute R2 belongs to either attribute R1 or attribute R2, and these two comes under intersection of R2. You get attribute R2. Okay, that is, if you intersecting these two means either R1 or R2 or combination of these three will get this attribute R2. Okay, so for this example, I have taken one example called, I have a relation on that I have 5 attributes called A, B, C, D, E. Okay, I divide based upon C attribute. Already you know the decomposition is based on by means of any foreign key attribute called he in this relation C is a foreign key attribute. Okay, so that I will get 1 alpha 2 alpha in one relation, and 1 alpha 1 and alpha 2 in second relation, like this. Okay, now you are joining these two relations, then automatically you get all this data. See, here to here you get this one, here to here you get this one. Join is like this one. Okay, you know that. And again, 2 alpha to alpha 1 you get this relation, and 2 alpha to 2. This is the relation. So I will get two relations, original relations. See here. Again, I am getting additional of the data. If there is additional of data, no problem. But we have to get a main relation. My main relation is only which consists of 2 attributes. I am getting the original relation. But when you combine these 2 or more relations, you will get the additional of some data. That is the lossless join property node point. That is, in lossless join decomposition, if you use some natural join property, then automatically you will get original data, and among original data you will get some additional data. That is called as lossless join. See, we will check out 2 or more additional examples. So this is one example. In this example, we can recover the original relation from the decomposed relation. So if you take the projection operator in relational algebra, you take the projection operator so that we combine this by means of the natural join. Projection is based upon particular attributes. So S2P and P, this is the main relation. I am dividing the relation by means of S2P and P2D. Now I am combining this relation by means of join operator. So S1P12 this row, S1P12 this row. There is no S1P1, no combination. So S1P12 P1 this row, S1P1D1, S1P1D3. Next, S2P2 common attribute is P2, S2P2 D2. Next, S2P1 D1. This is the common attribute, S2P1 D3. So that I have a 3 attributes. I combining by means of natural join. I will get only additional of 2 rows separately. Okay. And you take this another example. So this is the employee ID, employee name and age, city, salary, department ID, and department name. So you decompose that relation called employee table and department table like this. So I am dividing by means of employee ID. Okay, employee ID, department ID, department. So combination of these two. One is a employee ID and second one is a department ID. Now you are combining by means of these two relations. Okay, you will get a original relation. Okay, so you're dividing these two relations. So above decomposition is a lossless join decomposition because the two relations contains one common field called EID. So you combine by means of join operator, you will get the original data. There should be a we get by means of either original data or some additional data. Okay, so last topic is dependency preservation. Instead of going to discuss this topic, just I am skipping for today's class only. Okay, in this class only we discussed about only lossless join. In next class we will discuss about various dependency preservation. Thank you all.